All right, well, you know how this video is going to start. It's going to begin with our same equilibrium, our acid reacting with water, forming our conjugate base plus H3O plus. As it turns out, I've always shown this equilibrium. This is not the only equilibrium we'll have to evaluate. This is by far the most common form of the acid-base equilibrium that we will encounter. But there is another one. I guess I should say this is the more common form. There's another that we'll see that you'll encounter where the acid is actually written Hb+, because sometimes acids have a positive charge. Yeah, if this is the acid, it's going to react with the base. We'll stick with water. Now, Hb+ will lose a proton, and so we'll have neutral B with a lone pair, and that'll be our conjugate base, and plus H3O+. So this is less common. So in these cases, what did we say about this top reaction? To talk about this acid, we really need to discuss the stability or instability of our conjugate base, because if the conjugate base is stable, then it means this is a weak base. Stable is unreactive. Unreactive how? As a base. So it's an unreactive base. It's a weak base, and therefore the acid would be strong. Or we could flip it around. What if this is an unstable anion? It's highly reactive. Reactive how? As a base. Strong base, weak acid. Now, our base no longer has a charge. So to talk about the strength of this acid, we will talk about how the acid itself, we're going to look directly at the acid, how the acid itself stabilizes or doesn't stabilize this positive charge. So normally to talk about the acid, we'll look at the conjugate base. But in this case, where the acid has a positive charge, we will actually focus on the acid itself. This is less common, but we'll still encounter it. We need to be aware of it as we move forward.